So prime factorization is just simply writing all the prime factors of a number as a multiplication expression. So if you remember what prime numbers are, you can start to think about some examples of prime numbers. Prime numbers only have two factors, 1 and the number. So an example would be 2 or 3, 5, 7, etc. So we have 2 is prime because it only has two factors, 1 and 2. 3 only has two factors, 1 and 3. 5 and 7, the same thing. You can actually write any number as a multiplication expression with its prime factors only. So let's look at a few examples. We'll start with some easier ones and then move on to a more difficult one. Okay, so here I've got 16 and I want to write this as a multiplication expression of only the prime factors of 16. A lot of times when people do this, they make a factor tree. So that's one of the easier ways to figure this out. So let's get started. I'm making a factor tree with two branches, and I'm going to start with any two factors of 16. So I'm thinking of a factor pair 2 and 8. I could have also used 4 and 4. Okay? Whenever I find a prime factor, I'm going to circle it to show that that branch is finished. So 2 is prime, so I have stopped. Now 8, I keep going. For 8, I could write 2 and 4. Again, 2 is prime, so I will stop. 4 is not prime, so I'm going to continue. Okay, 4 is 2 and 2. So now I have 2 times 2 times 2 times 2. So think about that to yourself. Okay, that does equal 16. So you could think about it like this. How we are going to write it, though, is a little bit different. We're going to use our exponent notation. So 2 times 2 times 2 times 2 is 2 to the 4th power. If I write it this way, instead of using an x, I'm going to use a dot. The reason why we're going to move away from using an x is because soon we'll be talking about expressions that have variables. And x is a very common variable. So if I use it like this, it can start to get confusing. So we're going to switch to one of these two ways. Let's look at another example. This time I have 25. Okay? So with 25, my only option is 5 times 5. 5 is prime. So that means that my answer should be 5 to the 2nd power, or 5 times 5, okay, using a dot. If you're typing this into the computer, then you can use the caret that we talked about, or you can use an asterisk, which is the little star on the top row of your computer. Okay, so this is the prime factorization of 25. Finally, let's talk about a more complicated example. So sometimes you'll have a larger number and you will need to use your knowledge of divisibility rules in order to figure out factors to write here. Okay? So I am looking at this and I'm thinking I could use 24 and 10. Neither of these are prime, so I'm going to keep going here. So 10, I could write that as 2 times 5. Both of those are prime, so I'm finished. Over here, I could write 4 times 6, 3 times 8, 2 times 12. Doesn't matter. Okay? And then I just keep going until I have all prime factors here. So 4 and 6 were not prime, so I kept going. Now, these factors are prime. Okay, so let's see what we've got here. We've got a lot more numbers this time. So I have 2, 2, 2, 3, 2, 5. I'm going to group all of my similar ones together. So I'm going to write 2 times 2 times 2 times 2. And then I have times 3 times 5. I want to use exponent notation to simplify this. So instead, let me write this up here. I'm going to write 2 to the 4th power times 3 times 5. If you were to multiply all of this out, you would get 240 just like in our other examples. So prime factorization just shows a multiplication expression where it's made up of only prime factors and it equals our target number.